help you. Please be very text you. It's 1,000. My name is Daniela. Is there anybody that would love to get my number? You need academic advice, spiritual advice. Spiritual. Don't come to me for financial advice. I'll give you ideas. So see you next week. And then you can tell your friends to buy.
Good morning, students. I believe we deal with our physics math. Why? Please, if you have your own physics math, please help me with question 11. I know we've done question 1 so the workbook there, the workbook solved. Okay, that's the problem. We normally call it manual. So the workbook. That one is easy now. Should we?
Yes.
We let our body be just because and we want to convert it to the dimension. Because anything goes has to do with great dimension. So we have meter, which is MQ. As a unit. And the unit, the dimension of the meter is what? So it's very simple. Let's go to the next one. Number 12.
Dimension of acceleration.
Please, let's look at the part. I want us to solve at least 20 questions here so that we can
Dimension of acceleration.
Acceleration.
Yeah.
And we know that acceleration is equal to velocity. Please, let's be honest. And this one is meant as a meter per second. All over second. This is meant as a meter per second times 1 over s. This is meant as a meter per s. And this was so that's for unit of acceleration. But if you want to get the dimension, this becomes please, let's be honest. 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 I think I prefer it much more. Yes. I am giving number 13.
A car, which I shall press.
A car.
Which I shall press.
A car is initially at first. What that is trying to tell you? Please just read it. And I want you to take it. So this is a 25 kilometers. So calculate the time. So they gave me S and they will not give it to you. But please, as you are teaching, if you want to get parasology past question, you can meet Ella at the back. Yes. It's important. And please don't do it while you study the class. Just do it calmly. Do not disturb our class. Now, please, remember we gave you when we started this year. We gave you 3 equations of motion. We gave you that this equals to 2 plus 8. You still remember? Yeah. And let's say that this square is equals to this square plus 2s. You still remember? We also gave you that s is equals to 2t. So it's important. If you remember, the problem we used to derive all these formulas when we started, during our gigantic class was b plus over 2 times usually, but we are not seeing what we are doing equations that come as so it helps us to learn these formulas. Yes. So if you look at this formula now, which one do you think serves right for this question? The last one, because we have displacement, we don't have time, but we have acceleration. And we have initial velocity to 0. So let's practice some. So I have, sorry, so first of all, remember our principle, kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. You still remember? And I said, going this way is division. Why going this way is multiplication. The thing is now, the KM stands for kilometer, the HM stands for hectometer, the DM stands for decameter, the KM stands for meter, the D and the D stands for decimeter. And this one starts for centimeter, this one starts for centimeter. So now, since we are in kilometer, we'll call this 1. And we'll be moving this way. So how many zeros? 3. And I have 1. When I have 1 and 3 zeros, 1,000, right? I'm moving that into its multiplication. So I'll simply multiply. So when I multiply, whatever I get becomes my answer in million. So that will give me what? So that would give me 25,000. One more was this part. So you want to do the five this class? So about 25,000 is equal to this one becomes 0. And just like this, such an anything is 0. So because here is what? 0.5 over 2, then my t is going to be, I don't know it, so t squared. So you can see that this is the same as saying 25,000 times 2, or should it was to 0.5 t squared. I multiply, you have what? It's equal to 0.5 t. So we divide both sides by 0.5. 100,000. Do you know once you talk about money, you want to on the board. Some people are wishing. This will cast me is equal to t. Like I said, take square on both sides, right? Yes. So what's my t? 228. So C is approximately 316 in seconds. So you remember? Yes. So this is approximately 316 seconds. Give me the next question. Please, when you are coming for our Saturday's class, because very soon you will finish practical. Much of what we will do is your matter. When you are coming, find a particular notebook you are dedicating for your physics manual. So you use it and copy everything. When you start for your work, what I call this manual workbook is the same. The other one is practical manual. This one is actually your physics manual. Yes, so you dedicate a notebook for this, so you copy the answers into it. So that after you have to answer. So So question what now? The difference number 13. But one number 14. Connecting this. What about this? Connecting this. What about this one? Okay. Any thermodynamic process that we go. Okay, question 14. Any thermodynamic process
which takes place at constant pressure.
which takes place at constant pressure. But it's called dash. You know how some people do? You know what some people do? Some people just come and write isobaric finish. And notice that's the place that comes to people that take their time to make research. You just see somebody wrote isobaric, you go and write isobaric. It's correct too, but somebody that, let's say, is much more detailed than you will just come and say, it's called, you write isobaric, yes. Then you go on to define what this isobaric is and still give that the coined word for this is iso and okay, you know this. So he will still tell you that it's a Greek word, I see how he's gathering his mark. But you, somebody said no stress for that. The serious students will show you that they have space for that. They will really define it, you will imagine where is the space coming from. But if you just copy and paste. So, yes. So please, isobaric, once you're talking about constant pressure, this ISO is simply talking about once you say anything ISO, you come and it means like stable or stable. Yes. So, this one has to do with pressure. So if you know this, it simply means that even your water, when you are boiling water, if you notice, they will still teach you vapor pressure, second semester. It's under that vapor pressure, you might come to know about what we call atmospheric pressure. That there is a pressure that once you hit liquids, that when you get to that pressure, it will no longer be controlled by the atmospheric pressure. It will no longer want to obey it. At that point, you might get what we call boiling points. It will stop boiling, yes. The same thing with freezing as well. So once you are having to boil liquid or freeze liquid, it will obey you to some extent. It will obey certain conditions, and that means that the pressure is constant. But once it overcomes that particular pressure, it will no longer obey those rules. That's when you get it like freezing. That's when you get it like boiling. So the isobaric is correct. Now, what of the question about they ask you any thermodynamic process which takes place at constant temperature? Isothermal. So when I see that, I know it's isothermal. So very important. So give me the next question. You said if three. See, you said if three vectors acting at a point are presented a magnitude and direction by the side of a closed triangle. Taking in order. Okay. And I in the picture and compass, yes. Okay. Now, please, I want you to know that first of all, when vectors, naturally, you know that when you have two vectors, you use the hypotenuse to get the resultant. Is it not true?
Yeah.
And we call such process maybe your Pythagoras. But when it has to be above 90 or less than 90, you know that we normally use that our diagonal with two vectors like that. So any situation where this time around is no longer two vectors, but you are telling you three vectors being represented by a triangle. It simply means that first of all, those vectors are in equilibrium. And being in equilibrium simply means that the next vector J is 0. So it's a null vector they are talking about. And that will falls under what we call the triangular law of vectors. So whenever you are talking about triangular law of vectors, it simply means that you are talking about null vectors. So you are talking about 0 vectors. So why am I giving you this extra knowledge? Because it's not every time you just fix your mind that because they ask you this question, you just know this one. That question can be actually extended when you are expected to get a result from it. So that triangular law is giving you what we call null vectors. 3 vectors in the triangle gives you 0. So if we have that, when I say that this is going to be the triangular law of vectors. Alright, give me the next question. That's why it's important as you're in class, you fill up your notes here so that when you go home, as you're filling this manner, you are doing it properly, not just like your space.
Alright, I'll be going around giving the past question and signal me and get it for you. Don't forget that everything you need to pass exam, I pass this to you. It took our time to get those questions, solve them ourselves, and then we need to know. Because we know what we're ready to do. So if you need it, you raise up the stomach, you raise up the hand. We have math, physics, chemistry, biology, every medical pathology. Yes, you need to have the pathology pathology, if not for anything. In fact, you need to buy all as a medical student. But if you don't have money, you can start with the pathology. Thank you.
So please, you notice our computer class will be doing it on the WhatsApp channel, and from next week we'll start our computer class. We start at chapter 3. For those of you resuming, one of the reasons why we stopped doing computer is because we wanted everybody to resume school. So we start at chapter 3 in computer. From next week we'll resume our computer class. But if you've been following the online group, the online channel, that WhatsApp channel, academic that everything we've done in computer, we post to that channel. So make sure you guys subscribe to that channel. Just follow the channel, rewatch all the videos there. Academic that. And if maybe some of you don't come for lectures, you only get time to come for tutorial classes. Yes. So please, if today is your first day, I'll still drop my number to you so that you can chat me up. We need to chat me up. You get auto reply. If you try to join the first group there, it will not open because that one is full. So if you take this group as a filled up, or I don't know, but I know some people just send me this thing and they can't enter the group. So we created another one. So once you check that first one is not open, I will join the second one. Alright, give me the next question. Define simple harmonic motion. Question what now? Okay, this one is question. Please, we need to be fast. We need to solve at least 20 questions for that manual today. Yes, so we can go to another thing. Now, they said define simple harmonic motion. Okay. You can write simple harmonic motion is defined for SHM. Let me put it SHM. It is defined as the oscillatory type of motion. It is defined as an oscillatory type of motion, which involves the to and fro movement, of an object or say of a body of mass along a fixed path. So I said it's an oscillatory type of motion. I said simple harmonic motion is an oscillatory type of motion. You can also say it's a vibrating type of motion. You can also say it's a periodic type of motion, which involves the to and fro, or you say the back and forth. So you see, however you want to define it, back and forth or to and fro movement of an object, or you say of a body of mass along a fixed path. Big boys. You see that piece of food? You did here. Okay, man, please, see, to avoid using correction fluid on your manual, make sure you're not copying anything inside your manual. Now, use your notes and be copying this thing. The reason is that as you're getting the knowledge on your own, you need to add more. When you're looking for mark, you not add more from the summary. So it's not just taking it once, you are copying it, you need to gather more. Yes. So I said it's an oscillating type of motion, Chevy? It's also a type of motion, whichever way you want to put it, which involves the to and fro. I said the back and forth movement of an object, of a particle, body of mass. You know that objects, particles, all of them are classified as mass, body of mass, along a fixed path. Full stop. It is a type of motion whose restoring force is about a mean position. Restoring force is about a mean position. Now notice something. Please notice something. When you talk about simple harmonic motion, pay attention. Pay attention. If I happen to have this, let's say I have this now, and I have this to be my object. Notice that no matter how this thing swing, go, come back, swing, go, come back. Whatever is happening here is actually tied around here. I see it. Yeah. So there is a fixed position for whatever that is happening here. Yes. So that is why we say that it is the to and fro movement of an object along a fixed path. So it is very important to do that. So once you've done the practicals, that is why you do practicals. All this is. So once you've done the practical, you now have a visual or understanding of what it's all about. Because some of you, when we talk about simple harmonic motion, some people don't even know that even that your pendulum ball falls under this. Yes. Alright, so please let's go to the next question. Can I give on what? Examples like examples like what? Have you used bell in secondary school? Did you use bell in your secondary school? Did you use bell when you were in secondary school? Let me go to wherever you use it. As it's ringing, as it's hitting, listen, as you're hitting that bell, it's going up and coming actually, producing sound. So that particular pulse inside that bell is going to what we call simple harmonic motion. So there is no example to manufacture for this, but you understand that every type of motion which happens at a point being fixed and it travels and returns is simple harmonic motion. So once there is a fixation, it's not hard, it's simple harmonic motion. And which means, not for me, which means if tomorrow anything happens, not for me, then God is on record that you said you have the simple harmonic motion. So, but we can just say that it has a resemblance to it. Yes, it has a resemblance to it, but just that what happens with the heart is that it pumps and then it goes back. Not like it pumps and then. I know I'm not a biology student, but I just believe that if this happens to me, but when it's simple harmonic motion, you notice that whatever is happening, it has to travel the same length, full length of this, and then travel full length of it backwards. So for your hand, it's not maintaining that going up and coming down. It's just peaceful moving out and then coming back. But not really trying to go back to the original length because it's fixed there. So for simple harmonic motion, it has to do with going and returning. Maintaining the same length, moving forward, moving backward. But for your hand, it's already fixed. It travels back. Sometimes it doesn't even return with the same rates. Yes. Okay, it's one of the physics. Yes, but it's not a perfect example. It's not a perfect example. We can just classify it as a type of vibratory motion because we have things like periodic motion. We can just classify it as a periodic motion, but not really an oscillatory motion. So and fro to the fullest. Alright. Can seesaw. Yes, but not yes. Okay, do you remember in secondary school when you were doing all those jangolova? Do you remember? Yes. So, phonetic word. But during my time, we call it jangolova. The old people are calling it swing. My old people will call it jangolova. So if you notice, that your jangolova is fixed, like it has a pole. Shall let's say this is the side, this is the rope. You notice that, this is your place you sit. When it moves, it's come back. Shall Then you're using your legs to drag it back so that you get more momentum. This is a perfect example of synchronization. Yeah, so the perfect examples are more like you see it going through and coming back almost the same height that's left from the origin. Loaded test tube in water. I don't want to use biological examples or chemical examples. I'm teaching you physics, right? Yes. Let's think of it this way. Another perfect example of it is let's say your piano. Yes, your piano. If you are used to, if you can play piano very well, notice that you need to punch that key. When you punch the key, it travels the same distance that you move the chimney, then it comes back to its original length. There's a way you punch it, it will hit hard. The note will be very hard, and then it will turn back. So this is another perfect example of synchronization. What about? Right, but the only thing is that more like the fixation is not steady, it's not constant. So I'm using examples that have steady mean position. Alright, please, let's go to another thing. It's on your own now that you go and make as much research as possible. Yes, but the key thing is that you just need to understand that once it's simple harmonic motion, the key point there is that whatever movement you are making has a fixed point. It's about a mean position. Give me the next one. The two little blocks of modern. Okay, please, before we answer that question, let's try to see if we can remember everything we do in physics as a one student. Please pay attention. As a one student, the first physics you will do is what we call mechanics. Hope you are paying attention. The second physics you will do is what we call electromagnetism. Electromagnetism. The third type of physics you will be doing is what we call waves, sounds. So let me just do this. Yes. Now, waves. Under waves, you have things like sound, light, and rest. But under, light, you must find light under optics. Yes. So, the fifth type of physics we do is what we call thermodynamics. Thermodynamics. Why am I explaining this? I want you to use this and now understand what we're doing. Now, the sixth type is what we call modern physics. modern physics. All the physics you will come across, even for those of you studying IPH in second, I will study IPH in second year, first year, going forward. Every physics you will be doing falls under this. It's under this you have to classify things like astrophysics and the rest, different names to it. Now notice that when they are asking you, from that question they are asking you what and what? 2 million plus of modern physics, right? Yes. So under this is the one they are asking you. Notice that everything here for your first semester is more of this. Your second semester will be more of this, yes, and even this, yes. So in chemistry, so this modern physics is what physics and chemistry have in common. All those parts where you are doing proton, electron, some particles. Are you seeing it? Yes. Where you are doing quantum mechanics, where they come and tell you SPDF and the rest, all those things falls under this modern physics. So what they are telling you now is like, what are the foundation? So the foundation of this modern physics actually started with when the person was called Schrödinger and the Globis, when they proposed the theory. So these are German physicists. So they proposed a theory, and that theory simply, if you notice, all those things that normally teach under atomic theory, where they tell you atom can be this one, another person will come and tell you that atom can be this one, another person can tell you different things. Yes, but then they then came and said that you cannot find the movements of an atom and its charge at the same time. Now what you need to have is what we call the probability. And that probability that they gave us is what we call the quantum mechanics. Quantum mechanics. Can you hear me? So that is what you call quantum mechanics. So this quantum mechanics is what answered the question of, instead of this person coming today to propose his own theory, another person will come tomorrow and say your own is wrong. So it's in this quantum mechanics that they were able to say it is not possible to get electron as a particle and still get it as a wave at the same time. So that it has to be a probability, which is all those things that Prof was teaching you in chemistry the other day. I saw him teaching you SPDF and the rest. So this is the first building block of modern physics, which is quantum mechanics. Yes. Now the second building block of modern physics, in fact, the father of modern physics, you cannot even talk about father of modern physics or father of physics without calling a man known as Albert Einstein. Yes. So it was believed, even at death, when Albert Einstein died. I'm going to tell you about Albert Einstein here. Let me see. Yes. When you say what? Come again. Yes, okay, you are there, but we'll still come to that. See, when he died, the pathologists that took care of, you know that when somebody died, like they are doctors that check if truly this person is dead. The pathologist stole his brain. Have you heard of that? Yes. So he wanted to like confirm what is the secret of this man's genius. And what is it that made him that great? Even that pathologist lost his work because of that. They sacked him. And I think that should be in the University of Pennsylvania, something like that. So he stole the brain, they sacked him from work. So just to check how great Albert Einstein's brain was, or what made up that brain, because even during his lifetime they discovered that he was able to develop 6% of his brain, and they say that an average person develops up to at most 4%. Yes, so this is a man that in his lifetime was more like going outside physics. He brought theory of relativity. From there he was thinking of bringing theory of everything. Yes, you can't read about it. That's the only theory that he did succeed with. Yes, you can't read about him. That's the only theory he did succeed with. So he wanted to get a theory for everything, which I don't believe is proper. It doesn't look normal. Because what theory are you going to give for everything? There are people that are not very well. When you bring it together, they put it another way. So he gave us what we call the theory of relativity. And this is theory of relativity. When most people think of it, they think this is the theory that gave him Nobel Prize. Should be? Yes, he won Nobel Prize. He won Nobel Prize and is regarded as the greatest scientist of 20th century, 19th century. Yes. Just go make your research. Go make your research. So these are people that gave cutting edge. Yes. So please, it doesn't mean that we don't have other building blocks. It doesn't mean that we don't have other building blocks to modern physics. But these are the ones that like played significant role. Another person that could have played great role in modern physics is the man called Henry Moseley, the one that proposed modern periodic table. Yes, you know that the periodic table you use is a modification. Yes, and the next person that proposed it is Mendeleev. Yes, but the one we're using today is Henry Moseley's own. Yes. I'm not forensic inclined, but when you take me to spell, I will spell what I'm saying very well. Yes. So please, he is the man, but his lifetime was cut short because he was in the university system for a long time. Then they started doing World War II. He said he doesn't want to be an academician again, that he wants to go to war. Yes. So within a short space of time, he was able to bring modern periodic table. Within just space of time, something that took Rutherford a lot of years, and just give us, should I say, a miniature of what this man brought. So during that war, he was working as a spy. Like people that go around So from top of the roof, all this sniper, so there's another research I want you to make. So if not, this man played great impact as well when it has to do with building blocks of modern physics. So I want to, when you go, read about the English physicist called his lifetime. Right here to details. It will stay up so that as everything chemistry, because once we're talking about modern physics, is the same thing with the chemistry you are doing. They're telling you all those atoms, particles, and the rest. So the theory or any type of physics that involves all those things you learn in chemistry is a branch of modern physics. So we are making research on this man. Alright. So remember I said these are the 6 physics you will be learning as a student. And theory of relativity. Yes. So please, and remember the text I gave you for this. For quantum number is Schrodinger and the Broglie, and for relativity is about Einstein. So it simply means that you will go and make research on this paper about Einstein. Yes. All right. See you in the next question. Okay. And body question what now? 18. A body
Starts from rest.
and
Today,
Sherry, you know that once they tell you about the stars from rest, they're telling you that initial velocity is Sherry. What if they tell you a body is moving with a velocity of what I can say? They are telling you initial velocity. Yes. So they say body starts from rest, initial velocity is 0. Right? You go.
A becomes a direction of 5.5.
5.5
Calculate the distance traveled by the body is 27.
Okay, calculate the distance.
Traveled by the body is 20 seconds.
Okay, 20 seconds, Sherry. Okay, so remember we now know the equations of motion. You are giving the first one, call it out together. The one I want you to give me is the one that has to do with V as the subject formula. So V is equal to what? V is equal to U plus. Alright, the one I want you to give me now is V squared. The third one, displacement. Some people are adding base. It's well. I want to claim this. Please, try and participate. Shall we remember that we also have that S is equal to what does this thing stand for? Everything here, what does it stand for? Average what? Average velocity, right? And I think that when we did kinematics, we proved how Yes, we proved it. So please, if you are new to our class, we still do revision. But for the time that we have to do that, take your time and go through the notes. Check the notes of your classmates, then update it where we are. Now please, I want you to always imagine this as helpful whenever we are trying to derive equations of motion. Or whenever we are talking about solving questions under motion, I want you to always focus on this term. Can you hear me? Remember that the goal of you learning, the reason why you learn something is so that you get understanding. And in that understanding, you get simplification. That's the reason why you're learning. So, when we are deriving this, we have that mindset that everything here is important. But once it has to do with question under motion, you see that it's mathematics. Just focus on this. Now, if you look at that question given to us, they gave us S, and they gave us T. They gave us S. Or they gave us T. Which means it is between these two, but I'm going to use this one because I have to. Okay. So I have S is equals to, starting from X, and you will be 0 times T. Everything here will get out. Plus, what did I give for A? 5.5. What did I give for T? 20 seconds. Okay, 12.
Square. 20 square.
Okay, 20 square. Okay, I know now, but I just want to get your question. Alright, please. Once you have done solving and 20 questions for your manual, we complete our SCS class. If you have time to see if you can do your physics practical. You know, our problem is always fast at class. So, we need to be fast because we will still do math. Alright, next one. If you do 20 square, what do you have? 100. If you do 2 into 5.5, that's 5.5 better than 2. What you, that's my hand, so I watch. But what you're going to give me a and the unit is in meters, really? Yeah. That's our expression. Please always get in the habit of putting units for yes, for your value. I remember I told you that unit is defined as what? Define units. Unit is defined as Jesus Christ. Yes. Please get it today. Unit is defined as a standard for comparing or expressing physical quantities. As a standard for comparing, expressing physical quantities. It's just like if somebody come and say 20, you don't know 20 what the person is talking about. And the person says 20 that you know is talking about length or position or displacement. The person says 20 meters per second, you know is talking about the position. So it's a standard that gives you comparison. As to what the expression of. Okay, I said unit is a standard for comparing or expressing physical quantities. And we know that there is nothing like spiritual quantity should be. So it simply means that physical quantities are those quantities that can be measured. I am giving the next question what now? I am giving 3 forces. That is, let's say F1, F2, F3. Should we?
Yes.
I am 10 Newton and what? Okay, let me give you direction. I gave you this one to be what? No. Not. Okay. And east. Okay, can I ask us to calculate? And then I calculate the resultant simply means sum. Shall we? Yes. The sum of forces is talking about the resultant. You still remember? Yes. Why breaking down a single vector into x and y axis is what? The solution of the vector. So they can calculate the resultant. So see, I want us to check something. If this be the case for resultants, we need to ask ourselves, there is no angle here. Did they give us any angle? No. So there's not, everything is to not, this one to start to eat, shall we? That means we are not going to be doing resolution. Not that we don't have to go through resolution, but it's not really going to be us trying to do others that are pushing to this plane, pushing to this plane. I want us to now put it in the coordinates, our quadrants, coordinates, let's see what we have. So I will know that north we have 10, shall we? What about south? South we have 4. Shall we? Then east we have what? 10. So this is what we give to us. They will not give us anything for west. I don't have business with west. And remember that if I have something of this nature, this side is always plus. This side is plus, shall we? This side is minus. This side is minus. Is it not good? Plus, or minus, plus, because we said that x comes first. Minus, plus, minus. Do you remember? Okay. So let's now try to put this under x and y as because they are asking us for resultants. And we know that once we are doing resultants, whenever we are doing the resultant, our goal is always how do we get this to form a right angle triangle so that we can now use these parts to get our hand. Do you remember? So we want to put this thing now so that we will have everything to be the one on x to be for x, the one on y to be for y. So let's try to do it now. So here, this 10 needs to be only on x and only on y actually. So I have 10. That 10. When I have 10 like this, on the x-axis I have nothing. Are you aware? Yeah. When I'm talking about this 10, on the x-axis I have nothing. Are you aware? Yeah. Another way to do it is to remember that our concepts. Do you remember? If I try to, this thing is angle 90, but I normally think this thing is stressful, so you don't have to put yourself in trouble. Once you see it on y, give it to y for that particular point. So this is x. There's an angle here. If I start bending this angle, somebody will ask you, but you said the resolution is the one that you. So when you start bending this, you see that you are going towards cos 90. You are going towards this angle, shall we? Going to x angle. This is 90. And towards the angle in this cos, shall we? Yes. And cos 90, do you remember what we did? You said this is 90, shall we? Yeah. Cos 90 is 0. So what you can just say is not on x, just like this. This 3 newton is on which side? So it's only for x. Then for y is 0, shall we? Yes. What about this one? It's on y. Is it y? Yes. Is that in y? Yes. Is it y or minus y? Because this is plus 1, shall we? Plus x. Minus y minus x. So this is minus y, shall we? This is minus 4. So this one is 0. Now we'll do summation of the forces. So summation of forces. So punch for me. 0 plus 3 plus 0. 3, okay. 10 plus 0 minus 4. Is this what we have? Yes. So we'll be able to get x to have 3 and y to have 6, right? So at this point, we remember our cosine rule. But when you do it, you know that this is going to be, since the angle here now is 90, if we do r squared equals to x squared plus y squared minus 2xy plus what angle is here? And cos 90 is 0, shall we? Yeah. So 0 times everything here. So this is how we get out Pythagoras squared. Everything here we get out. So we are left with just x squared plus y squared. So now let's substitute. So we now have x for 3, and this is 3 squared plus 6 squared equals to r squared. So that means that this is going to give me 3 squared is what? 9. So I have 9 plus 8. Okay. So I have 9 plus 6, which means that r squared is going to be 9 plus 36. Okay. So I can say that the square root of both sides. Well, once on me, what do you have? 6.708. Like this?
Yes.
Okay, which is the same as saying R is approximately 7. Shall we know? And unit is in Newton. So R is equal to 7 Newton. This thing is not R. I know we love vectors. It's not hard. But number one, now.
What's the equivalent of 1,000?
What I like is that we are fast. That's the problem.
I think this type of course now that they are directly can you just say one minus to another one?
Direct opposite how?
Like example, instead of directly
No, it's not possible. You know, I see. See why it's not possible. When you're talking about this force now, this is what we call coplanar forces. See his question. He's asking, please pay attention. He's asking if, as I'm giving 10 here, because this is normal knowledge. As I'm having 10 here, I'm having 4 here. He's asking, what if we say, since this side is, everything here is y as it should be, and this side is plus, this side is 1, what if we do 10 minus 4? So that's what you're saying. We do it once, and then we get that 6. Is that what you're saying? Yes. See, the reason why you're saying this one this way, and it's peaceful to you, is because there's no maybe extension of plane this way. So what we normally consider when we are doing this is actually the concept of coplanar forces, which is if I see a force at the quadrant, resolve it first. If we do it that way, it will give us an answer. But it only works when everything related is maybe on vertical and horizontal. So if you are using that concept, you might enter somewhere where you have something on Z plane. So for coplanar forces, you resolve individually. Alright, so the next question. Are we doing? Yeah. So we can solve 20 questions today. Right, I just want us to finish our dynamics class, then solve our practical question. So we'll try. Yeah. Wow. Question 20, shall we? 20. What is the equivalence bands? Okay, what does that mean to you? Okay, and it's a question. Okay. So they are asking us for equivalence of what? Please, do you remember the last class when we did egg per second, ERG per second? Yeah. What did we say that day? Yes, we did very important because we have that 1 meter equals 100 centimeters, should we? Yeah. And when the 1 meter equals to 10 is power 5. So we are trying to use that concept. So when I say 1 meter will give us should we? Okay, but they are asking us for 9 now, should we? So I can say the 9 I don't know. You know that anything you don't know is called 9, should we? And it's equals to what? And this part I can apply here the common mathematics. So I will now have 1 Newton and x times, should we? Then equals to 1,010 raised to the power 5 times. Don't worry. You are switching to the shop from the job DSC. Don't worry yourself. Nancy, you remember this is what I want to go subject of formula, should we? I say divide both sides by the ratio, which is 1 Newton. 1 Newton. This will cancel this will cancel. So x times will equals to I have one for me. So it will be this one is 10 raised to the power 3, should we? So times 10 raised to the power 5 times. So I have your physics law. So we can add up the powers since the bases are the same. So this is 10 raised to the power 8 times. So that's my answer. Please. What's the next question?
On that 9
Can I copy this thing deeply? very neat about it. And then a man has been 100 over 100. Then I will be put down. Yes. If you know, when it comes to excellence, it's not a joke. If you ask your medical students, or if you see results of medical science students before you, sometimes you see the result, you think maybe they were inside the hall and the vigilators around and use notebook and textbook. You see somebody getting A, everything. It's not a joke. You see students, like a student getting everything for that first semester. A's throughout. It's not a joke. Somebody will tell you that his GP and GP is 5.0. He says it's a lie. The person will show you the proof, he says it's a lie, it's a detail. It's real. It's blocking you. So, what is the correct claim now? I can claim this one. If you can't see very well, you buy specs. If you go to hospital, tell them you need medication, medicated glasses. It will even make you look finer, sharper, and you will be deceiving people with it. Sometimes if you see a student on glasses, you automatically see the person low. Yes. Especially if the glass actually have low. So if you have any issue saying before, you can use the wine. Each time we say I'm listening to seven, you go to hospital, tell them you need medicated glasses. But please, if you don't have eye issue, don't even try it. Because sometimes when you start using that medicated something, it will spoil your eyes. Yes. Yes, it will spoil your business or retina. So please, if your eye you can see very well, don't even try it. Don't do fashion. Don't use fashion like you yourself. Some people I know, eye very normal. They start wearing glasses. Before you know it, they are looking for their eyes. So please, don't try and do fashion on it. I say, you see what is the equivalence of 20 what now? Okay, for 190 kilometers, 190 kilometers per minute. Switch SI. Okay, first of all, see how we do this. We'll ask ourselves, this 90 kilometers is such as if I write 90 kilometers, I write over minutes. Should we do? Now, but I know that the SI unit of minutes is seconds, right? Let me just find it one side. And 1 minute is equal to 60 seconds, right? And kilometer, you still remember, that means if you don't put it inside of those, kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter, kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. If you are going this way, you are dividing. If you are coming this way, you are multiplying. Now, what do we mean by that? Notice that since we are in kilometer now, we'll come and say, let this be, we are moving from kilometer to meter, that's what we want to do. We'll come and say, let this one be 1, because we are talking about kilometer. Every other thing becomes 0. If you have 1 and 3 zeros, it's 1,000 shilling. And moving this way is multiplication. We'll come and say, okay, that means this is the same as 1,000 meters. Are you saying it?
Yeah.
Okay. Now the next thing we'll do is this way. We'll then try to say when we are multiplying this, we'll try to put kilometer in such a way that kilometer will cancel kilometer. So we'll try to put this thing in a way that we'll come and say all over 1 kilometer equals to 1,000 meters, shall we? So let's say that kilometer is here. So we'll come and say 1 kilometer so that this can easily cancel this. Then is equal to 1,000 meters. Please, you see this thing I'm teaching you. most students, they know everything, but once it gets to this, the confusion will arise. So once you are doing this, always remember what is equivalent to. Then you are now checking how you are not doing it. I think kilometer is down here. I think kilometer is down here. When I want to do it, I will put it to the up so that it will cancel this one. So I will not say again times, because I'm seeing minutes here. You see that? And I notice that I have to put minutes in a place where minutes can cancel minutes. Then I'll ask myself, 1 minute is equal to what? So my seconds will be here. So minutes can take your place. So I say 60 seconds equals to 1 minute. So at this point, cancel, 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 cancel. Per point, you see what is remaining is your answer. 1,500 and it's a meter seconds. We said that say 1,500 meter per second. This thing is very important. Please, first you know what it is. You know the conversion formula. First, you know the conversion formula. Second, you need to know that whatever you are given needs to be put side to side so that the one you have or can cancel the one down. The one you have that can cancel the one or. Very important. Very important. Okay, somebody paid for tutorial fee and threw away the receipt. Child of God. Who is this Daniel? You first see the day of recording. The time is coming when if we come towards the exam, we say, okay, you've not paid, where is your receipt? We come, no receipt, please leave. So it's not supposed to be inside your book. The other day, where is that my friend? She puts money inside book. Then was working and the book went to submit her notebook. The money fell from the notebook. Luckily for her, this American came to call me, says, come and see. We pick it, then she asked, sir, that money is my money. I put it in my. So please, stop putting this in your notebook. If possible, go and buy water glove. You mask it at the back of your notebook so that anytime, any day, you know it's yes, so please, don't lose your receipt. If possible, sir, you also snap it. You can also snap this receipt. Very important. So we are done with this question, question 21. So let's go to the next one. Okay, another convert. Yes. Question 22? Yes. Okay, 22. Wait, let me have you one competition. Convert an acceleration. Convert an acceleration of 200 meters per So with this concept now, doing this one will not be a problem. Should be good. So let's try to do it together. Can I come in? So remember my principle: kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. So I already have it. I have something meter, I have something centimeter. So see what I will do. I'll just come and say, they gave me acceleration, convert an acceleration of 200 meters per second square. So you want in kilometers per hour square. I'll just say, I have 200. And it's the meter per second square. Should be 6. Then I'll come and do times. The first part now I'll say meter. We have to be in a place where meter can cancel meter. Then kilometer will fall. Then times. I have second square here, should be? Second square will be in a position where second. Okay, please be fast. Let's use this side. I want to play this. So I have 200 meter per second and it's having square. So in converting this, I have times meter being in a position where meter can cancel meter all over kilometer. I will ask myself, how many kilometers is equal to 1 meter to meter? So 1,000 equals to 1 kilometer. So I go and put 1 kilometer, then I put 1,000 meters. Very important. Then times, you know some people, you know some programs some people will have, they'll be asking themselves, why is he every time he's putting 1,000 meters? Please, these two they are not mates. You see it, this one is bigger than this. I say for this one to start before this one, it must come with 1,000 of it. I say it, yes. So for there to be any association, all you will come to 1,000, yes, it will. Just like if you want to bring money to a white person now, maybe you carry 200 naira to give somebody in the white person, your money will just be like trash because they can't convert it. So it's true now. So that means that if you are actually doing this, you will always come with meter that is equal to 1. That's why we're always using 1,000. Then the next thing is to put this again all over. Nothing that seconds is down here. We need to put seconds and it's in square in a position where it can easily cancel seconds square. Then we'll ask ourselves first of all, this time around, how many hours? 1 hour is equal to second shilling. Because this time 1 hour we have 6, now we have seconds. 60 seconds, 60 times 6. Alright. So that means I will have that first of all. Let me remove this, so that we don't get confused. So we say 3,600 seconds is equal to 1 hour. You mean? But notice that this is a square, right? So for that reason, the seconds I'm putting here will be square. So I don't have to put this, but I will still put it. So the seconds I'm putting here is going to be a second square, seconds that is square. So by the time I do meter, take care of meter. I want you to know that the second square that I'm having here simply means that this 3,600 will be in 2 places. Are you seeing it? Yes. So as if you are doing seconds, it's going to have just 1,600. If you are doing second square, it's meaning that the time there will be in 2 places. So please, what you do for me now, so that you don't just go and cancel this thing, cancel it, you come and use this value and multiply. That's the progress of the one. So what this thing means is that you should square this as well. Then the unit is this. So by the time you now say, okay, you can cancel this, the value will be a set of the progress. So watch, whatever you get is your final answer. So what is your answer? So here now, 200 times 1 divided by 1,000, then times 3,600, whatever you have, you have to do. And this one, this one will be square.
Yes, it
will be square now. Yes. Alright, so do for me. I have 2 million. 2 million. Okay, sorry. So, and it's going to be what? Kilometer. Then remember that we square this, Shebi? And that square now is coming for this. All over our square. What is not confusing?
That's confusing.
Is it confusing? See, let's do it again. We have, first of all, we have 3,600 to be for 1 hour. Shebi? Let's confirm if we are correct. We know that setting up the values is right. So I think the problem we're having is from where we put the square. So we are moving from this square to this square. Shebi? Yes. So what it means is that we should have 1 hour to the 3,600 seconds. Then we should have 1 hour square to be equal to 3,600 seconds square. Yes, that's it now. So that by the time I'm putting this, what I'm actually supposed to put by the time I'm putting this is to remember that this one is going to be a square. So the only problem we have is that when we equated this, we're supposed to put this one in square, this one is square. You said? No, it will not be the difference. See, the only problem we have is we know that 1 hour equals to 3,600 3,600 seconds. Then the next thing that we should convert from hour square to second square. And 1 hour equals 3,600. So it's just 1 hour square that we are converting to, and it's going to be 3,600 square. So because you know that if you do one square is 1, times hour square is still going to give you hour square.
Oh, we are not converting hour square to. We are converting from second square to hour.
I know. See, listen, see. We are not converting actually to seconds. What we are converting to is hour. But our hour needs to be in seconds. That's because the reason that we should convert an acceleration of 200 meters per second square to a value in kilometer per hour square.
So I think to clarify this thing, you have to convert that to back meter per second square. Let's check if we get to 100.
We'll check now. We'll check. It will still be correct. Do you know what's that? Even if you get it wrong, if you try to convert it back, you still no. If you get it wrong and try to convert back with the values you used to get it wrong, you still get a good answer. So let's see what we are doing. See what we are doing now to confirm if we are right. See what we are doing to confirm if we are right. We know that 1 hour is equal to 3,600 seconds square. Now, 1 hour square is going to be the same as saying 1 hour square, because by the time 1 square is 1, that's hour square equals to 3,600 square. And it's a second square. So by the time you do this one in 2 places, whatever it is equal to this hour square. So what we now do, the only problem we have is that we don't put this square initially. So let's check if we are correct by converting this now back to meter per second square. It's not hard. So the only problem we have was just that we tried to push this, so we should be correct. Let's check. So I have this time I have 2,592,000. Shall please pay attention in kilometer per hour square times. When I ask ourselves, remember that kilometer will be the place that it can divide 1 kilometer. Now that this is going to be 1,000 meters. Because I've noticed some of you have been copying without paying attention to this arrangement, that is this cancelling arrangement. 10 times our hour is here, we need to put our square in a position where it can cancel second square. Now notice, our second square is going to be what? Then our 1 hour square. So you see that by the time you do this, this one, sorry, this will take care of this. This will take care of this. I have punched the way. Let's see what we have. Are you sure? See, please. You have to watch this thing 2 times, so you get 200 watts. See, the only problem we have when we started is that the 1 hour we did not have an X square on top of it. That is just it. But
So if you do that, converting 200 that is not kilometer, that is giving you 20,000. Then if you now use 20,000 guided to divide by that, give the whole balance.
no, you did not do it according to how it was done. You are doing manipulation. That is manipulation. You place kilometer. See, did you place kilometer where we place it? You place kilometer where we place it. And you see that attention to 1,000 equals to 1 kilometer. And kilometer should be in the place where it will cancel. Did you do it like that?
I don't use it.
Once you are not using this, I know, you know I'm saying it. I've seen some of you. As I said, how you go to copy things online. If you are not putting this thing in a way that kilometer and kilometer must cancel out, you end up making mistakes. That's the truth. You will always see, first of all, you need to know that 1 kilometer is equal to 1,000 meters. And knowledge of it alone is not enough. The knowledge will be useful when you know that whatever you have given to you should be placed in a way that whatever you have will cancel the other one. If you are not placing it that way, you end up getting it wrong. So the only problem the only reason we wanted to have part. Here we have second square. If we are using just second, because that's the problem with some people. If we are using just second, what is now the meaning of saying second square? So the value of seconds is 1 hour is equal to 3,600 seconds. So that means that 1 hour square should be equal to 3,600 square in second square. So that's what we are paying attention to. Yes. That's what we are paying attention to. So we are very correct. Alright, so please, let's go to the next one. The second one is question 22, shall we? Okay, this is 22. Okay, 22. Okay, we're giving question 23.
Show that the dimension of power is given as x always equals to
Okay, it's more like them asking us to show the dimension of power.
Yes.
Okay, can I explain?
Yes.
So please, we need to try so that we can complete our question from the episode. So that I will be sure that from next week we are entering a new topic. So from next week we will enter work energy and power. Yes. So that we need to finish work energy and power, we look at moments. 5 minutes. Show that the dimension of power. Dimension of power is given So we should show that power is given as ms squared t. Why I like this is that you don't even have to cram. You don't have to maybe start saying, let me make it so that it will work. The minute you are not doing it properly, it will not work. That's it. Right? Please, hello. What some of you are used to, any little thing that you're seeing the formula, you want to go to AI and punch it. Even sometimes even if you put, for example, cosine rule or parallelogram rule in that area, the only value it will bring out for you is going to be r squared equals to n squared plus y squared plus 2ab cos t. This is what it will give you. Watch it now. The reason is because it has already done whatever it is that all those are our processes that we normally pass through. So it just give you the one that it wants to give you. So please,
this formula was not what you wrote about that.
You said?
The formula was not correct.
And this formula, see, this formula is actually a rounded up formula for all those things we are doing. Because by the time you do 120, and plus 120 or plus anything above 90, and it means it will not give you plus. I seen it, but remember that what you are going to ask it is for cosine rule. Is it not true? And it's giving you this. And if you check it, at the end of the day, everything you have here is more of that parallelogram. That's what you have. Because that's what that parallelogram is trying to tell us. How do we make it so that our final value will have a positive sign? Alright, please. First of all, power is the rate of work done, shall we? Okay. And we know that work done is equal to what? Is it first times distance or first times displacement? First times. You are for distance. You are for displacement. You are for distance. Let me see your hand. You are for displacement. Let me see your hand. Please, the two are correct. Hope you know. Because distance is the same as displacement. It's just that we normally say that displacement is senior brother to this. Because it talks about direction. So I normally tell my students to take work as first times displacement. Because work is a scalar. It's a scalar quantity. And when at first times displacement, this is vector, and naturally, when I have vector times vector, then I'm going to have a scalar. Yes. So that's why we normally use displacement. It doesn't mean that the distance is wrong. Alright. So let's now put more power to that formula. So the power equals to work over time. If somebody is faster than you, can you say that that person has speed power than yourself? Shall we? Let's say ocean boats now. We are on ocean boats. You people are on both of you are on. Who is going to come out faster? Me. See, if you are coming first, you have power. When you have to do it, that's speed power than ocean boats. But I know it's not possible because you are not that trained. Ocean boats is the same. So in your place, they don't even have time to come and do all these things you're doing. So when you call him ocean boats, he doesn't care. So this is going to be force and displacement all over time. Notice that something looks like what we do here. This thing can also give us that power is equal to force times velocity. That's what it means. So as you progress in level, you will still be meeting this, especially for second semester when you be doing resistance currents. You come and skip us converting this to so many things. But what we are looking at is how do we make power to be equal to this. So I'll ask myself, what is the SI unit of displacement here? Look at your name. What about power? What about force? Because force is equal to mH, so it's going to say kilogram meter. Is it true? Yeah. And this one is seconds. Okay. So let's try to convert. If we are converting now, this is being separated with multiplication. So that means I'll have kilogram meter times meter. That is this meter. Then times s raised to power minus 2. Then divided by s. Is it true? Yeah. Which means that this will be the same as saying kilogram meter squared. Then s raised to power minus 2. Shall we? All over s. Don't be faster than your shadow. Please take it step by step so that you don't enter confusion. Sometimes people will not answer to questions, but when they come out of the exam, they see that they face some kind of things that they don't want to face. So step by step till you master it. So this is the same as saying kilogram meter square per second square times 1 over s. Shall we? And we know that once 1 is a numerator, it means that the one at the denominator has a negative power. So this is the same as saying s raised to power minus 1. And now, since the bases are the same, you can say add the powers. So that this now becomes kilogram meter square. Then s raised to power, the bases are the same, minus 2 plus minus 1, which is going to be minus 2 minus 1. So kilogram meter square, s raised to power minus 2. Alright, so at this point, what they are asking us is for dimension. And remember we said that dimension is the measurement of physical quantities using mass, rate, and time. Shall we? Yeah. That's what we said. So kilogram is for mass. Meter is what? And it's carrying 2. Then s is what? And it's carrying minus 3. Does it look like what they gave us? Yeah. Okay, this one is 1 hand. This one is 1 hand. This one is 1 hand. So please, I want to play a copy. We are looking at time.
Yes.
That's the problem. Because last week we dismissed late. Yes. And sometimes when you dismiss late, sometimes we call you.
Yes.
Moto almost jam my daughter. So I'm saying, is it me? No, I'm strong. I'm fit. I'm doing it. I should be strong. It's AI, people like AI man. Alright, let's go. Guys, give me the next question. Mr. What's now? Dimension of pressure. We've done this one before now. It's looking too simple. Because we don't have pressure. I don't know if for pressure is stress, maybe. Or we say position. Let's just pass over here. I don't even want to do this one. This one is too simple. Because I know that this is going to be kilogram, meter, second square. Shall all over meter square. So let's this go here. So I have kilogram, second square. All over meter. And this is going to be sent as saying 80 times 1 over n times 10 minus 2. And 1 as soon as it means this one, it must be 80 Shall we? Now, once we are done converting to each unit, we now start putting it to dimension. Kilogram for mass, m for length, and this is t for s. And so it's very simple. So we don't have to do things like this again. Please, those of us that always have issues once it's time to convert, pay attention very well to this one. And please, one of the things that will help you is when we solve a particular question and it's confusing you, you try it in different ways. Like try it on your own over and over and over. Try different questions to see if it can work out. Alright, let's say convert a density of
10,000 grams and 2,000.
10,000 grams?
Yes.
And?
Okay,
gram per centimeter cube.
Yeah.
Okay, let's say we should convert the density of 10,000 grams per centimeter cube to what?
SI.
To this SI. And we know that the SI unit of density is what? Kilogram per meter cube. Do you know?
Yes.
And we know that density, the formula for density is mass over volume. Is it not true?
Yes.
Which means that density talks about how deep something is. Like in Igbo, you say EMG. Is it not true? Yes. What you're saying is density, the depth of something. Yes. So now let's start converting. Please pay attention to this one. Notice that there's nothing like square anywhere to confuse us. Or to make us start punching AI. So I have 10,000 grams over centimeter cube. No, show me that once it's coming down, I don't have to put down minus 3.
Yes.
That minus 3 stands that it's over. It's at yes. So I'll now tell myself, how many kilograms make 1 gram?
1,000.
So it simply means that 1,000 grams gives me 1 kilogram.
Yes.
So anytime I'm comparing, what I will now be checking is simply what am I converting from and to. If I notice gram is up here, I'm moving from that to kilogram. I'll put gram in such a way that it will be down, so it will cancel. So let's say, let me carry it to times 1,000 grams, 1 kilogram. then times again because it's a centimeter cube. Now I need to ask myself, how many meter? Because how many meter make 1 centimeter? 100. So what we can make 100 centimeter should be? I hope you still remember that our table. Please memorize that down to the top button. So that means this will give me 100 centimeter. But remember that what they're asking me is that this is in cube. So I'll simply say, if this becomes centimeter cube, this is their same principle that we use for that seconds. If this becomes centimeter cube, it means that I should have 100. That is in 3 places. 100. 100. It's not just the units that you put in that cube. You will also put the value of that in the cube. Yeah, so this is the same as saying, how many zeros now? 6. So 1 meter, which means that 1 meter cube will be equal to 1 Look at it very well. So understand what I'm saying? Like look at this very well. So I mean what will it see what it simply means is that if I have centimeter cube, it's the same as saying 1 centimeter times 1 centimeter times 1 centimeter. And 1 centimeter, sorry, 100 centimeter gives you 1 meter. Is it not good? So if I have centimeter in cube, it means that I have inside that centimeter to be equal to 1 meter. I have that centimeter in 3 places of 100. Because 100 centimeter equals to 1 meter. So 1 meter cube equals to 100 centimeter cube. So what I will simply do now, since I know this thing now, my goal now is to put centimeter against centimeter. So that I can cancel that. So I'll come and put centimeter cube over meter cube. Then I'll put the value 1, 2, 3, 4, 6 against 1. Because I know that the 1 meter, if I do 1 times 1 times 1, still 1, times each meter that will multiply 3 times 1m times 1m times 1m. The only thing that will multiply is just the meter cube. Is it not true? So you see, you get the better understanding of all those things. So now, you now have centimeter cube. Take care of centimeter cube. Gram. Even see, if you even want to do it this way, if you don't want to just cancel, you can say, if gram cancel this, let it cancel all the things about gram. So you see, it's only 3 zeros you can cancel. Is it not true? Yeah. So we'll now move. The remaining things there will now give us kilogram and meter cube. So please look for me. 10 times 1 times 1. Okay, 10 million. So the value will be 10 million. Please, if you are not using what we are doing here, you must fail it. It's not a joke. That's the truth. If what we are doing here is not what you are using, you must fail it. So make sure that you are learning this approach, so that when you go as you are studying, you are not adding your own understanding to it. Yes. So it's very important. So please, let's put it on so that we reach the last one, which is number 30. Today, yes, please, that will give us a question. Today, I will be teaching you how to derive all those formulas for circular motion. Yes. Today, that will be the last one, and number 30. Yes, that will be the last one. Then we'll now go to our class because we have to do math. So please, give me the next question.
Because of 15 years.
So 25, okay? Okay, a first of them. Okay.
Ask of the body.
Ask, yes.
Calculate the X component of the body. Of this body.
Okay, calculate the S component.
Of this body.
Yes.
If the hand is pushing doesn't force.
If
If the angle between the resultant force
Yes?
and the x-axis is between
Okay, between the resultant force.
and the x-axis, you can have exact
What are you doing?
X-axis is 30 degrees. Okay, just like this. Wow. So, I said a force of 15 newtons, that's just one force, acts on a body. Then after calculate the x component of this force if the angle between the resultant force and the x-axis is 30 degrees. Okay. Well, let's try it. So what I mentioned is x-axis, not the y-axis. So let me draw this. Please, once I start telling you about x-axis, you know that everything that happens, like anything that happens in all this our physics, mathematics, what they are testing is the way of reasoning. Yes. So the minute they start to put it to you in a particular way, you need to just decode what they are trying to do here. So this one now they are telling me about x-axis and y-axis. They didn't mention y-axis. But automatically, I know that I should be thinking of x and y axis automatically. So I will not be checking if the force given to me is acting on the negative x axis or negative or positive x axis. So I have plus here, I have minus. They did not mention y, but I put it here just in case to be sure. Now they tell me that if the angle between the resultant force and x axis, and they told me a force of 15 to act on the body. Okay, calculate the x component of this force. Let's say this is the body. Let's say this body is on the x axis because it's happening on the x axis. Yes? So they're not telling me that the angle between the resultant force should be calculate the x component of this force. So let's say this is the angle between these two. Let's say this is 30 degrees. Yes? So what I'm checking is to know if that force is actually on that horizontal or if it's the one at the angle. Yes. So it's at 30 degrees. So because I know, why am I putting it this way? Notice that they almost confused you with putting resultant force here. I said it. Yes. They almost confused me with putting resultant force here. Because, yes, see, what this thing means is that if this happens to be a triangle. If this happens to be a triangle, that there is an angle between the resultant force. Let's say this is the F now, resultant force, and the x-axis. So if you are not careful, you might end up putting that force here because of the way it's stated. And I know that resultant always have time to put in this. Is it not true? Yes. So that's why it's been as if I was taking that. So I have 50 Newton. But notice something. Whenever I have something at this end, it simply means that I have to resort to the x-axis and to the y-axis. But notice something, please look at this question very well. If you notice, you see that what they are asking me now, that 15 Newton that I have, simply happened in such a way that if I'm taking this down to this place, it's going to be cos. And if I have to take it to this side, it will be sine. So this is what they are expecting from me. They said a force of 15 Newton acts on the body. Calculate the x component of this force if the angle between the resultant force and x-axis is 30. If I don't want to do x and y, I can just say, since there is a force acting on the body along the horizontal axis, it simply means that I can also remember from yesterday's class dynamics that F cos theta will be equals to NA, but they did not give me and they did not give me A. Shall Yes. So that means I'm left with this. I seen it. As when they gave me MA, that is mass acceleration, I can easily do this. First horizontal axis times the angle equals to MA. But since they did not give me MA, I'm going to use this. So I will now put this in such a way that I have my x-axis, my y-axis. Hope it's not confusing. Is it confusing? Okay. Please, I'm just putting it to you so that if you see the question, it's not cramming you are doing. That's why I'm explaining it this way. Okay. They said a force of 15 Newton acts on a body. Okay? Now they are asking you to calculate the component of this force. In the angle, they are asking me to calculate the x component of this force if the angle between the resultant force and x-axis is 30 degrees. So I have a force and I have this to be my 30 degrees. Shall we? Yeah. So if I have it this way, even if I say let this force now not be here. Let's say I say let this force not be here. I say let it be here. Let's say I say let this force be here. I will still have my angle that is still 30 degrees. So relax. So you see that it's not cramming, we are not doing cramming. We are trying to see that we are not cramming this work. So you see that in this case now, if I have my resultant force here, what I'm going to do is to resolve this to x-axis and to y-axis. Should we? But if I have this to be on this side as my x-axis, what I'm going to resolve is only that 50 meters is on the x-axis. And y-axis is going to be 0. See how to do? So between these two now, I have to choose which one we are using. Between the two, I have to choose which one we are using. So see, why am I going to be using this? Why am I going to be using this? Why am I going to be using this? Sorry, it's because they mentioned that the resultant force makes contact with this at 30 degrees. If I choose to use this thing, I don't know that force. I don't know what force is here. Is it making sense? Yeah. If I choose to use this, it's not like a resultant force. It's this one, this thing that I have is a line that is making an angle with this horizontal. And they did not tell me that this horizontal is making an angle with this resultant force. So it's not cramming. I'm actually using based on the what I asked. Even if we don't find y, we need to find x. But we must find this because of the situation of the question. Then when I give the answer for the x-axis, it's not hard. Please ask your question before we progress. You know, this question looks tricky. That's why I had to interpret it in different ways. Some persons, when they see this question, what they will be stuck with is simply f cos theta equals mk. Then when I start asking, what do I use as my mass? What do I use as my A? But for the fact that you're in this class, you know that this will not work. Because of the fact that there's no mass, there's no acceleration. So I'm left with two options. Now the two options I'm left with now is for me to check which of the forces makes, in which way do I place this force and it makes contact with the horizontal at 30 degrees. Is this one. If I take this of this is not a force. So that's why I'm going to use this. So it's not confusing. And it's not like cramming. You don't have to cram it. You just have to analyze all the things we pass through, then we see what we're doing. Now, please help me. If I carry this force now, and I'm coming this way, I'll have what?
50 plus theta. 50 plus
50 plus 30.
Yeah.
Okay. If I carry it and go to y, what will I have?
50
times 30. So please punch for me what you have. 40. For this one. So please, when you are doing 3.30, please when you are doing your work, remember to always write everything I'm saying. Write the reason it's given. So that you don't go and then when you are ready to get confused. I have 50 seconds. 25. What's anything? Just like that, Sherry? So please, if the angle, they say calculate the x component of this force. So what this thing means, even, see how you even know if you are correct. See how you know if you are correct. If this is a resultant force, they are not asking us from the question to find resultant force. Are you aware? What they are asking us is to calculate the force on the x-axis. So by the time we do this, whatever we get here is our force on x-axis. Whatever we get here is our force on y-axis. It's very simple. Ask. What if you just do? You see what we are doing here? See, do you know what our students? Most of the things you people gather is cramming. That is why some people enter exam hall, they're forgetting. What's here? See, he's cramming. What? See, watch. Naturally. I hope you know that naturally, it's not every time that X is cos theta and Y is sin theta. But we only know that X is going to be for cos theta and Y is going to be for sin theta when the angle makes contact with the horizontal. Is it not true? That is why we have to draw this. So if you don't draw this thing now, how will you know? You will learn it. This next one now. So see, even if for example, let's say I want to bring it. See, let's say a question is given to me. They tell me that there is a vector that makes 150 degrees. Let's say there's a question given to me that says this vector makes 150 degrees. Let's say I have 5 here, let's say I have 4 here. Hope you know that if, for example, I want to draw this now to be vertical and horizontal. If I want to draw this now. Remember that if I choose to maybe start using from here, this point, that means that the principle I want to use is actually parallelogram, not resolution. If I want to make this to be a resolution of vectors, I will simply say, if everything here is 150 for resolution, this is the angle I will use. So I'll make it to touch the horizontal, so that I can be able to use X to be cos, and whatever is not going to Y will be sine. So that's why I'm showing you this vector. But please, if maybe you like shortcuts, you can still remember that force on x-axis is always F cos theta. Provided you are showing that the force makes contact with the horizontal, and this one is always F sin theta. But if you don't draw it with all those our presentations, all these things now, you won't be able to know it's the horizontal. Some persons can just come and say 50 here, 15 Newton. They don't know what they are doing here. So that's why we are doing this. No, we must be correct. If we are not correct, we start making trouble. Have you forgotten? Till we are correct. That's why we are learning. And that's why our class, if you notice, in our physics class, we don't do anything by assumption. We always do, at the end of the day, we give you proof whatever we are getting. Yes. So yes, for your X, the force on x-axis is going to be 43.30. That's the answer. Yes, in Newton, yes, in Newton. Your force on x-axis is going to be 43.30, while your force on y-axis is going to be 25 Newton. Very simple. So please give me the next one. Question what now? 27. So please, when you finish doing this, imagine you are doing your own, you are showing them all these steps. You tell me that the lecturer will not honor it. At the end of the day, you even come, after you are done, you now come and say, force on. You know, there's a way you will just be doing your work if you are serious about math. Whoever is marking it will know that you are not joking. Yes. Now come and do force on x-axis equals to 43.30 Newton. Very simple. Very simple. All right, please. 27, give me the question. The area under a velocity time graph represents what? You are seeing now? We should use the diagram to illustrate our answer. Wonderful. What I'm saying, see, if we have this side is velocity, should we?
Yes.
If we have this side is time, shall we?
Yes.
Let's say this is seconds. Let's say this is equal to a second. Okay. And we know that velocity time graph, the normal rotation, there are rotations where this thing can go like this. Go like this. Even maybe go like this. Yeah. There are different rotations. But the routine or the base rotation is that we know that we normally go this way, and come this way. And we told you that anything this side is for acceleration. Anything this way is acceleration. Just pay attention. Somebody will still ask me, sir, what you just give us the answer. Please, draw this thing. So when you are doing your own now, you know how to carve out your own point for it. anything this side is retardation. Retardation is simply negative acceleration. So this side is plus, this side is minus. Now, whatever you have here shows steady speed. If you don't call it steady speed, you can call it constant velocity or constant speed. If you don't call it constant velocity, you can call it maximum velocity. Or maximum speed. So there are different names you can call it. So you just need to know it. You can even call it uniform. So you can even call it uniform. Yes. Yes. Why are we doing all these things? Please, take time, however we put it, please master all of it. Because it's not once that they will use one that we did. They can use any one. So when you see everyone come out, you know how to go about it. Alright. Now there's something I want us to check. I want us to check something. If you do velocity times time, what do you have? Are you sure? Velocity times time is what? Do you know there's something that comes, they say you're a science student and you are very good. Some of you, the problem you have is just you want to just come and copy note and go home. That's what I'm saying. Because there are some questions that you just twist and ask. You know, it's giving me another thing. I know that first of all, velocity is equal to displacement over time. So if I cross multiply, velocity times time now will be equal to what? Is it not true? Shebi? And notice that everything that is giving me all the things I have here, if I take the value from here or whatever, I get my acceleration. Notice, as I'm going this way, everything here is velocity. Is it not true? Shebi? And everything this way is time. Is it not true? Yeah. Is it not true? So it simply shows you that the area under a velocity line graph is simply the product of velocity and time, which is displacement. Very simple. That's what it shows you. So the area, I did not say the slope. What this thing shows you is that the area under a velocity line graph is the product of velocity and time, which is displacement. The slope, we'll still get to that. If they ask us slope, what we have to check is how we get slope is simply to remember that slope is the same as saying vertical divided by horizontal. Is it not true? Yes. And the vertical this side is velocity, meter per second. The horizontal this side is time. Is it not true? Yes. That is my slope. So if I want to get my slope, now what my slope will be, I will say meter over s times 1 over s. This is the same as saying meter over s squared. Is it not true? Which is the same as a meter per second squared. And what is that? Acceleration, yeah. So the slope of the velocity time graph is acceleration. Very simple. It's not hard. So what you are just telling when they ask you the area under it is to remember, why did I do times? Somebody wants to ask me, why did you not do times? I know that area naturally has to do with 2 dimensions, which is vertical and horizontal. And this is meter, this is meter. And that gives me meter squared. Is it not true? So by the time I take the value here, instead of meter, what I have is velocity. Here, instead of time, what I have is, instead of another meter, what I have is time. Is it not true? So if I do meter, and this time is now velocity times time. And what this will that is displacement. Very simple. So the area under velocity time graph is displacement. Very simple. Alright, let's go to the next one. Can I get it?
Yes, of course.
You are giving.
Velocity of the path will be meter per second varies with time.
Watch. Velocity of a particle in meter and varies with time, yes. Okay, there's an equation there.
Yes.
Okay. Equation.
B equals 83 minus 40
Plus 4. Like this.
yes.
Okay, what is the velocity of at what? Attained by the okay, is that all?
Yes.
Copy. Can I claim? I want to claim. Okay, so first of all, we need to remember that when we started class, when we started kinematics this semester, I told you that if I have, for example, displacement, and I have velocity, and I have acceleration, I told you that the minute I'm moving this way, notice that inside velocity we normally do velocity is equal to change in displacement over change in time. Is it not true?
Yes, sir.
And the mathematics for second semester when you will doing calculus, they will tell you that change means differentiation. And inside acceleration we have change in velocity over change in time. Is it not true? Yes. So this is the reason why I normally tell my students, instead of speaking this change, leave it for engineering students. You are a medical science student, don't speak change. Just speak arrows because you will do biology and you need to be pointing arrows. So I'll just say if it's going this way, I will differentiate once. So if I'm moving from displacement to velocity, I'll differentiate once. If I'm moving from velocity to from displacement to velocity, I differentiate once. If I'm moving from displacement to acceleration, this is two movements. Is it not true? Yes. So I'll differentiate once. Yes, I will differentiate twice. That means that if naturally once you're talking about differentiation, even when differentiation forms a quality sign, it becomes integration. The same thing with the way you do in square plus a quality sign, it becomes square root. Square root plus a quality sign, it becomes square. So for that reason, if it's going into a differentiation, that is if I'm coming from this way, A to B will be integrate once. Which means if I do A to displacement, I will integrate how many times? Integrate twice. Okay, what if the only one that can integrate or differentiate just once is this one? Because it's in the middle, is it not true? So if velocity is moving to acceleration, it will differentiate once. If velocity is moving from velocity to displacement, it will do what? Integrate once. Very important. So this one now, if it's moving this way, integrate, or let me use this symbol for integration. This thing stands for integration. It will integrate once. Another way to put integrate once is simply, you select a symbol, then put one sign on it. Like this one now, it means the symbol 1, the symbol 2. Therefore, this differentiation, I can say the symbol for this B1, this one B2. This thing means twice. So if I know this, we can now look at that question. So the question says velocity of a particle in meter per second varies with time according to the equation. And I ask what is the maximum velocity attained by the particle? And we know that maximum velocity simply means steady speed, should it?
Yes, sir.
Or uniform speed or uniform velocity. And we say that at uniform velocity, what happens? Acceleration is zero, should it? Do you know that once I see an equation like this, once in physics, I see velocity of displacement or whatever, having an equation, two things must come to my mind. Those two things are am I integrating or am I differentiating? Now, do you know the reason why I will differentiate? I will only differentiate because I saw maximum velocity here, which means that they want me to find acceleration when it's zero, when it's equals to zero. Are you seeing it? Yes. So since they mentioned what is the maximum velocity, I will have to differentiate because I know that maximum velocity means something. And what does it mean? It means that at maximum velocity, acceleration should be equal to zero. So that is why I will go and differentiate. If not, I can at this point choose to integrate. So why I'm going to differentiate there is because of that maximum velocity. So let's try to differentiate. It's important to notice all these things I'm saying. The minute you see an equation, you are bound to differentiate or integrate. Alright, so with that said, I will now apply differentiation rule. Have you copied this? Yeah. Okay. So solution. I told my students sometimes you don't know the answer to a question, but you need to write solution. The answer will come. It works like magic. You see some people write the exam hall, they say it's too old, their handwriting will change to be very fine. What are they doing? They are thinking of answer. Yes. So the inspiration will come. Now I have the, this is what I have, equals 3t square minus 4t plus 4. So if I'm going to differentiate, it simply means that I'm doing the v over the t. Somebody wants to ask me why I'm using the v over t. I'm differentiating velocity with respect to the time. I cannot come and say the v is z or the v the y because there is no y anywhere here. I'm only differentiating with respect to the things I'm seeing. So this is the sentence I say you differentiate velocity with respect to time. And you know that once you're doing this, you're talking about acceleration. So this is equals to, this is going to be 3. Now see, to differentiate simply means whatever the power is, use it to multiply the number, the coefficients. Then after you do it, you now minus 1. That's the difference between integration and differentiation. So I will do 2 times 10. 6. Then I will do 2 minus 1. 1. But assuming it's integration, as I have 3t first power 2, I will first of all, instead of dividing, I will first plus. I see it. That's the difference. In integration, you first plus, then you now divide. While in differentiation, you first multiply before you subtract. So assuming it's integration, I will do 2 plus 1. 3. Divide with that number. Very important. As in science students. So I'll now move to the next one. Minus. There's an invisible power here, Sherry. So 4, let's go at t. 1 minus 1. Plus, what will this be? 0. The constant term is 0. So I now have that this is going to be 60. 1 minus 1. Everything let's go at 1 times this. So this is saying 0 square, so which is 1 times 4. So I have minus 4 plus 0 no use. So I have acceleration to be this. Now see, notice that as I have my acceleration to be 60 minus 4, everything here should be equal to what? 0. Why am I putting it equals to 0? 1. You understand it? So please, we've been able to get A. Why I'm removing this A is that there is how it looks when I come and put A equals to. Are you seeing it? Yes. But you just know that the value I'm getting here, whatever I'm getting here, is my acceleration. What I've gotten here now, 60 minus 4 equals to 0 is my acceleration. So at this point, something looks like I can make it solid of the formula here. Yes. See, Shelly? Yes. So I will have divide by cross equality sign. See, okay, so I'll have 60 equals to minus cross equality sign. 4, Shelly. So I can say divide both sides by the coefficient of t, which is 6. This will cancel this. 2 here. 2 here. Shelly. T is equals to 2 over 3. 2 over 3 is equals to what? So 6, 7. The next is to just not 6, 7. Shall we? In seconds. Alright, I've gotten T to be 0.6 seconds. But notice that that's not what they're asking me. Is it not true? So remember that at a maximum developed as an acceleration which is equal to 0. I'm able to get my time at that point to be equal to 0.67. Is it how to do? So what it means is that, remember this is my V. Are you aware? The minute I differentiate this becomes acceleration. The minute I integrate this becomes displacement. So if I want to do anything for velocity, it's still this value I will use. So for that reason, I will come back and say, since V equals to 3t square minus 4t plus 4. And at maximum velocity, which we will prove here by making it equals to 0. We got that t is equals to 0.67. This is less than 0.7. So V should be equal to 3 into 0.67 squared minus 4 into 0.67 plus 4. When you are finding velocity, assuming this displacement they give you here, and they're not asking to find velocity at maximum whatever, that's when I will have to differentiate that and get the velocity there substitute. Because this is velocity that I'm doing. So please, at this point, do for me 0.67 squared times it with 3. Then, in fact, do the math here, give me your final answer. Because I've noticed once I say punch, we have issues. Do all the solving. Give me the final answer. Some people don't do solving. What they are waiting for is let them punch it. Please punch.
2.667.
Everything is 2 points.
2.6667.
So 2.6.
667.
Okay, 10 times.
Yes.
Okay, that means in meter per second. So this is my velocity, and that is the maximum velocity attained. Do you know why? Reason is that maximum velocity attained. Reason is that when you have your maximum time, at maximum time, or should I say at maximum velocity, you have the highest time. Are you aware? Yes. So and we know that when we quoted this to 0, we got the maximum time to be 0.67. So we can use it to work out this. Alright. So please call the next question. Is that what can I claim?
No.
The ball is kicked into the air. And then see, let's put it this way. Do you remember when we did projectile motion? Listen first. A ball is kicked into the air. Is it how to? How projectile now? See, what's the simple harmonic motion? Hell! Zachariah! See, a ball is kicked into the air. Traveling is slow. Once you notice that thing, the movement of that thing is something that if it go, it doesn't like come down immediately, or it doesn't go straight. So if you kick that ball, it will have to travel in a path that will bring it down like a curve. So it's projectile motion. So that's one of the things you need to be thinking of. We've done projectile motion. We still do all these courses we are doing, but the idea is important. It's important to stay remember all those concepts we use. So a ball is kicked into the air, let's analyze it. So let's say the ball, this is the ball, and this is the ground line. What we are going to be checking is all those places of the projectile motion. Is it starting from the ground and coming back to the ground? Or is it starting from behind and coming to the ground? Or is it starting from the ground and then stop at the hand? So read the question. The ball is kicked. At the end of I/2 radian. And please remember we said that radian is the SI unit of angle. Do you remember? Yes. And it's a dimensionless because radian means angle length over arc, and all of them have meter. Meter divided by meter 1. Okay, at the angle of pi/2 radian, to the horizontal. So with the velocity of 12 kilometers per hour. You know that? Okay, that total period of flight. Okay, they're asking us for T. That's what it is. So remember, even if you don't believe it's a projectile, the minute they say they keep the ball, you do not go horizontal. You use horizontal as kinematics we use. But they say to move that an angle. That means to trace the parabolic path. So they're asking us to calculate the total time of flight. That is time for you to reach maximum height and then come down. Do you remember? Yeah. We've done it before. And say that time to reach maximum height is equal to u sin theta over g. Yeah. Why this one? If it's in this case, so this is a case 1 projectile. Because it's in this case, we just do go up, come down, 2 u sin theta. There are cases where it will not be the same. So you need to go and study, look at those videos we posted on the group where we have different cases of projectile motion. So for this case, we are going to use that T is equals to 2u sin theta over g. So it's important that as you're in these tutorials, you are not having any conclusion. One of the things students want to do is they want to have a conclusion of this is the principle I will be using when it's projectile motion. If you are using this particular principle for anything projectile, you will be done. So you must memorize the different cases. We have up to 6 cases of projectile motion, and I gave you the formulas. Yes. So you need to be noting. Alright, now we have kilometer per hour again. We need to convert to meter per second. So I will say 12 kilometers per hour. Let's try to do it in 2 seconds. So we simply do 12 kilometers over hour times, sorry, 1 kilometer, then 1,000. Okay, master here now. Then times 1 hour. Then you must start it. So this take care of this. This take care of this. So I have 3.3. So we are left with 3.3 meter per second. Very important. Even if I'm handling this, what only thing you need to know the equivalence. Then another thing, know that if you have this here, the other one should be down to cancel it. If you have this here, the other one should be up to cancel it. Very simple. You don't need to be thinking too much about it. So we have 3.3 meter per second. Now again, another thing we need to know is that in secondary school, the total time is equal to 22 over 7, Sherry? Yeah. And this 22 over 7 is when it's the radian. Are you aware? Yes. Yes. But in degree, what is pi? In degree, what is pi? So when Master will be teaching you maths, he will still tell you about the model. When you have the same things like pi over 2, pi over 3, pi over 4, pi over 5, it means so many things, pi over 6, going around. They will come and tell you what all those things mean. Yes. So in this case, they told me that I have pi over 2 as the angle shading. Yeah. So if I want to convert it to degree to the 180 divided by 2, which is what? 90 degrees. In this class, we are not doing guesswork. If what you are doing maybe is how to put the thing so that you guess it and forget what it will be hard. So try and be following the steps. That's where everything comes from. So the step is very important. Alright, so we've gotten our U now. So this U, the U we'll be using is the SI unit, which is 3.3 meters per second. So we converted it. The degree we'll be using is going to be 90 degrees. So in that being the case, you can now see that we've gotten everything we need because G is a constant. We can use G to be 9.8 or 10. And why I'm using this formula is because this first product is 1. No problem, it's very easy. Because very easy. So I say T equals to 2 into 3.3. Sine 90 degrees. All over, I can use 10, I can use 9.8. If you have this thing now, what do you have? 0.67. I know that the unit of time is seconds, really. So I'll just say 0.67. And we say T approximately 0.77. Or we say approximately 1 second. Well, let me just give it to you. Alright, give me the next one.
okay. Write down the expression for the total force.
Okay, that means we're number 30.
Yes.
Write down the expression for centripetal force. Please, if up to now you've not gotten past question for physics, okay? Do you know why? By January, when we come for tutorial, you will be imagining, is it really true? Like if you just ordinary tutorial, imagine, is this thing really true? You will be seeing people, and people are outside. Then, it will look as if maybe by then you are doing what I've been coming for the tutorial. Why don't you understand me? Because without understanding by then, new students will be around. We normally do this class batch A, batch B, and batch C. Ask your seniors or ask your lecturers if you're close to them. Admission that they will be giving in this school is always close to 3,000 to 2,000 plus for these students. Ask questions. It's very too much. Somebody said it's too much. It's very too much. And time will come in January if you are coming to hobby. From this massive of if you lose you'll be asking what is happening. Don't worry. For now, you see people standing outside. You think people are standing outside. This one is just standing on floor. And they have admission from them. Say, even after first semester exam, there's no admission. Somebody say, what will not happen? Those people will come and do what we call more. Yes, they list first semester. They now write what we call more exam. That mock-up is not carryover, but you are writing because you missed, you came late. So you hear people announcing mock-up practical, mock-up test, mock-up exam. So that mock-up time is when everybody will go to that season. So why are we saying this? Now that all these things are close to you in a way that, or should I say, we are waiting for the real people that will come to school. Because you now, you are no longer real. You have become original. So you know there's difference between real and original. Do you know? Yes. You are the original student. By then, there will be the real students of year one. You will be original or old takers. Old school. Yes. By then. So please, do whatever that they are saying, past person is so amount, buy it. By then, there will be no certain as those of us that started so time. No. Things like that will happen. Yes. Alright. So, the last part of this question, which is the last question we'll be treating for today from that manual, before we look at our physics dynamics. What's the time? Okay. Let's say by 2. We'll end up. I will finish physics by 2. Then we'll have 2 maths. Okay, see. Just the table gap. Made dynamics, just some questions we dismiss for physics. For physics, how can you come and not do maths? Are you okay? You are making it look as if, but just we come. Once the program will rush and come in, so that you will start class before us. So please, let's just start. So see, they give us what is the read that question again.
Write down the expression for the centimeter force.
Okay. Okay, that means they are asking us for the formula, or is it the expression for centripetal force, yes. And what is centripetal force? First of all, what is centripetal acceleration? Please, the short form for you to remember it is that centripetal means P for pointing. So more like center pointing. Centrifugal, F for fleeing. Yes, of living. So let's leave fleeing. So we say center fleeing. So when it's leaving the center, we say centrifugal. When it's pointing towards the center, we say centripetal. And so that way you recognize it. Alright, now let's try to look at this. Let's try to derive those equations. I told you that in physics class, you don't do cramming. What you do in physics class is you know how to come about. And when you know how to came about, it becomes easy for you. Anytime they wake you up to ask you, you know it is diluted. And that is the same thing with a skilled worker. If for somebody that has a skill, even if they're like maybe for 50 years, many things that you can start it again, it will take small time to adjust, like for it to be sharp. but they are not learning it. But the minute they do it for like some weeks, you see that yes, this person is an expert compared to somebody that is starting. Maybe for instance, for those of you that know how to barb hair or to fix hair, by the time you go maybe a newbie, if you can't touch the person's head, there must be a problem. It's not compared to somebody that left it for you. The person will still have an initiative to put things together. Alright, I have a circle.
Yeah.
If I have this circle, this part, let's say this is the part that is the center, right? Anything I do here, what would I call this? The extent from this point to this point, what is it called? Radius, right? Let me call this R. If, for example, you know that as something is moving around this circle, please pay attention. Because in this one, if you're not paying attention, you must call me down. It's the same principle with kinematics, but it's just that when it's circular motion, you are having both the horizontal motion, the vertical motion at the same time. So in kinematics, if it's going horizontal, you know it's horizontal. If it's going this way, you know it's this way, shall we? Yes. And it's projectile motion, if it's going this way, you know it's vertical and horizontal. But in this case, you are having the same thing at the same time. So that is why we can say that something has constant speed, is circular motion. But you never talk about constant velocity because at each point, the velocity will be changing. So for that reason, let's say that when we have this end now, this is R, at this point, let's say there is movement. Let's say we call this place initial velocity. That is trying to move down. Now, let's say there is a distance occupied to this point. Now, let's say this is another length that has been occupied by this. I'm coming. So this is going to be my another arrow shading. Yeah. Let's say we call this one arrow 2. Now notice that at the point where these points upward, at this point, I have another velocity. Do you agree? So let me just say I'm using these two. I call this one V. No, I'm using the velocity we normally use V and V now. So I don't have to put V1 velocity. So at this point I have arrow 2. Now, notice something. Let me just use it's the same arrow that is here, but it's another one. Shall we are saying it? Now, notice that there is a change in position here. And we know that anytime we're talking about change in position, we're talking about displacement. Is it not true? For now, let me say this is displacement, or let me say this is change in displacement. Now, I want to carry everything and see it out. Let me just clarify. This is the principle used when you're talking about something. It can go around different segments, but we are just using two segments to judge for others. So let me just clarify. I have, and this is the same way. This is R2, this is R1, and what I have here is my change in displacements. Very simple. Now notice something. This is the velocity. Is it not true? Final V. This is another V. If I use the principle of tail to tail. We did it in an addition of vectors. When we did addition of vectors, we did tail to tail. And we did head to tail. Just stay there. Just stay there. At this my end, I'm going to leave for you to tail. Please. See. This is the tail of this, Sherry. I watch now. I'll bring it out. Bring this one out. Now see the arrow here. See the arrow here. So what this thing is meaning is that if you check the velocity is occupied or attained by this displacement because of this length, that is almost the same direction. If you put it there together with this. So let's say this is not the part of the U, this is not the part of the V. And notice, Sherry, this movement is going this way. Is it not good? Yeah. So I can have this way. Which means even this one that is going this way, that I put arrow, is also going this way. I can have this way. So this becomes change in V. Because we know that anything change in V means final against initial. That is final minus initial. Is it not good? Yes. So I have the length, which is the radius that it will be occupying. Then I have the change in displacement. Now, once I have these two things, the principle now for deriving the equations. And what are the equations? When it's circle or whenever it has to do with motion, you must be able to know what displacement is. You must be able to know what velocity is. You must be able to know what acceleration is. And for circular motion, the thing you call velocity, which is v, once it has to do with circular motion, is represented with w. I will call it angular velocity. While the thing you call displacement for circular motion, you call it theta. Are you seeing it? Yes. For circular motion, theta is the same thing with displacement. While for our normal motion, displacement is s. You need to know these two things. Alright, now please, there is an angle here. Let's say we call this theta. Or I say change it theta. So there's also another angle here. I call this theta because that is it. So judging this by the fact that they have the same position, with that means there's an angle here as well. Theta. Since the circle we are talking about, even its motion, even its velocity, is giving you the same angle, moving at the same angle with what you have inside. So if I know that, I will then ask myself, if I have this displacement, which is change in displacement, I want us to notice something. By the time I do R2 times theta, it should give me everything here. Do you agree? Yeah. And by the time I do R1 times theta, it should give me this. Do you agree? See, up to this point, do you understand? Yeah. Up to this point, that is how we brought out this our radius, and we know that this is changing displacement because of the position from this end to this end. Then, this one, what if you don't understand is this thing?
No, they have to
this triangle. See, is this thing is the same thing that I have here that I have here. I can just do with your Caesar. So I'm not saying changing as displacement here. See R2 here. See R1 here. See theta. Now I want us to do it this way if you're not understanding. What do you think I will be able to do with this theta and R2 to get this change S? You will see, what is missing now? See, what is missing is that I have this full area, which is giving me this angle, Sherry, and I call it theta. By the time I judge whatever I have here with the length I have here, which is the R times R, it should be giving me delta S. Delta S, that is the change in displacement. This is the change in displacement. Now I want us to do it this way. If I have this change in displacement and I know that theta in circular motion represents displacement, is it not true? Theta in circular motion represents displacement. If I then ask you the change in displacement now for this particular thing, let's say we are not seeing this thing now. We want to find the change in displacement. It can be two things, which is R2 minus R1. And this is using the principle of our kinematics. Stress line motion. Now, in circular form, you can very well say that this theta stands for displacement, which is the change that happened here. And when it happened here, at what axis? So if I'm judging to the left, it's going to be a product of this displacement and R2. If I'm judging this way, it's going to be a product of this displacement and R1. So that is why I say that this change in S is simply also the same thing for circular motion. The same thing as saying theta times R2. It is the same as saying change in displacement is the same as saying theta times R1. Yes, at what axis is happening and the displacement. So remember that when we are doing this thing now is we are using the delta S. Even you see delta S, we are using delta S. We are simply using a principle that comes from kinematics. Because we say that in circular motion we have both the kinematics, the linear motion, and the curved motion. So when we are using delta S, it's simply we are trying to put it with the straight part of it. And when we are using theta, we are trying to talk about the circular part. And when we are talking about velocity and we are using V, we are talking about our linear part of the motion. And when we are using W, we are talking about the curved part of that motion. So we've been able to put it that if that is the case, we have that delta S can mean theta times R2. Delta S can also mean theta times R1. But notice that the measurement from here to here is the same thing. So it simply means that delta S is the same thing as simply saying theta times R. Or in some books, or in some textbooks, like maybe when you are reading, you might see change in theta times r is the same thing they are talking about, or r times change in theta is the same thing they are talking about. Like an s equals to r times change in theta is the same thing they are talking about. It's not to be confused. So if I know this, since we said that what we have here is the same thing with what we have here, let's use the same principle and get change in v. Let's use the same principle. It simply means that change in v will be equals to, change in v will be equals to v times change in is it not true? Yeah. And that is change in v can also be the same as saying u times change in theta. Or they don't have. Because I know that if I come here and tell you maybe that this is another thing, there must be a problem. So it's not hard. Now that I know this, now I'll never ask myself. Ask. Why I'm calling it change in theta is because this theta, actually, even if I use theta, there will be no problem. But this theta actually will not be stable, like it will be moving to different angles. Remember, when we are doing motion, giving your displacement, all those formulas they normally give you velocity equals to displacement over time. It's supposed to be changing displacement over time. Even that in the time acceleration equals to velocity over time, it's supposed to be changing velocity over changing time. So anything that has to do with motion is always changing this over changing this because it must be changing. Yes. So if you see a place already, I'm just telling you it's equals to this, they are just trying to make it simple for you. But the actual thing is that there must be change in it. So that's why I'm putting it to the fullest. So that when you see it somewhere, you're able to know all of it. So now that we've gotten to that part, let's keep moving. Pay attention. Once you know this thing, you have learned it, you don't like your name. Alright, now let's progress. We now need to remember. We now need to remember that we talked about W, first of all, from our secondary level of understanding. If we remember what we've got here, we got that change in S is equals to change in R, then change in theta. Should be? Is it not true? Yes. From what we got here, this side, is it not true? I don't want to be doing anyone and be flowing, and you're not following. So we must be responding so that I'm sure. Let's say we want to make change in theta, so let's have the phone. Yes, it's number 30 we are solving, but we don't just want to give you formula. We want to derive it. Yes, that's what we are doing. Somebody said, you see number 30 we are solving. Do you know many times some people will claim that formula? There are people that what they just do is mv squared over r. Finish. They claim it for that moment. After that moment, they forget it. See, there's someone that don't like easy life. Are you aware? Checking everybody like easy life. Do you know? Yes. But the only truth there is that when we want to like going extra mile is simply the legacy that comes with it. Yes. So if it's maybe your protocol is that you want us to be just giving it cheaply to you. We'll be giving it cheaply to you. You go, yes. But I like if you are going through your notes, remember how to do about it. So that if you see a question in future, some of these things you see us doing are principles that when a question comes on a second question, you are not just deriving the formula, but now the concept will be leading you to think through on that question. So you guys like this is the I say, let's say I want to make change in theta so I can phone here. What will I ask? Remember size my hand, should we? Okay, so that means that change in theta can also be the same as saying change in S over R, should we? That means even here, if I want to make change in theta so that's the formula, it simply means that it can also be the same as saying Change the V over U, shall we? Now we need to remember from secondary school they told us that W is equals to change in theta over change in time. Did that tell you? Did that tell you? See, now see. First of all, velocity. What is velocity? Displacement over time, shall we? And I told you that for circular motion, remember I said now, more like we are simply thinking of the straight line part of the motion. While more than the W, we are thinking of the velocity of the curved part. So notice that here I have displacement of the curved part. Is it not good? So change in theta, which is the same thing with displacement. Then change the time, the same thing. So it's not to be confused. Now, if I know this, I'll now ask myself, from here we have delta theta. Or change the theta to this. Is it not good? Yeah. So let's say we try to replace change the theta here with this. Are you seeing it? Yeah. Because why am I doing this? Because the reason why I'm doing this is because the velocity, the curve velocity that we have will experience even displacement on the linear path. So if I replace this change in theta here, I'll have that W is the same as saying delta S over R, shall we?
Yes.
Times 1 over delta T. Do you agree? Yeah. And if you look at this very well, W is the same as saying delta S. I will put it in a place where it will favor what I want to say over delta T times 1 over R. Do you know what I use this thing to achieve?
No.
Velocity. Because velocity on a straight line, the linear velocity, is the same as saying displacement over time. Is it not true? So I have that W is the same as saying V times 1 over R. So you see that W is equals to V over R. So I'm able to get angular velocity. And this is the formula for angular velocity. So this angular velocity is simply showing that in as much as we have the change in theta, that we are going to be experiencing circular motion and as well as straight line motion. We are going to get W. Now the next thing we need to get, so whenever they ask you, what is the formula? Is it I'm coming? Any question they ask you, anytime they ask you, what is angular velocity? What is the formula for angular velocity? That is the formula. Angular velocity is simply velocity over very important. Now please, let's move, let's progress. Acceleration. Remember that the question they asked us is the acceleration, should we? Center pointing. Centripetal force. Yes, now we cannot get centripetal force without knowing the acceleration. Because force is equal to mk. So acceleration is equal to, remember that from our straight line motion, acceleration is equal to change in velocity over change in time. Yes, sir. That's why if you are an engineering student, once they talk about all these things, it will not confuse you. But you just need to know this. That's why another person will normally say velocity over. It still has changed. So you need to notice. Now please, if you go back and look, when we got change in velocity, we got change in velocity from this our movement. And change in velocity is equal to V delta theta. Is it not true? Yeah. So which means that A is also the same thing as saying, let me replace. So remember, you can say remember that delta V is equal to V delta theta. So if that be the case, you now see that A is equal to V delta theta. That is for this. All over, I still my delta C. So I have all over delta C. Is it not true? And now notice that A is equal to V times delta theta over delta time. Look at this, it looks like something. Is it not true? Delta theta over delta time is what? Shall we? Yeah. So this is the same as saying that F is equal to V times W. I see it. And then that W is the same as saying V over R. Is it not true? Yeah. So this is also equal to V times V over R. So A is equal to V squared over R. So this is my acceleration, centripetal acceleration. We've been able to derive it. So once they ask me to get force, All I just need to do is to simply put M close to it. Very simple. So that means that F equals to MA. So F is equals to M. Like I said, some places you will see F equals to M with what we did here, VW or WV. M equals to VW. Or you can see it as F equals to MV squared R. Yes. So this is my final answer.
Wow.
Yes. It's to yourself. Congratulations to yourself. You know I say congratulations to yourself. When they start marking down your manual or when you start submitting, you will not use it. You know I like this school. Before your exam, your manuals, especially chemistry department, they must have marked your manuals, brought it back to you. So you, in your mind, you are a very intelligent boy, and what your intelligence is that you must know the correct answer, you put it. When you come and see half, in front of the man, you're going to write 6 to 30, 5. Wait, and you see it as a prophecy. Then your pastor will come and be telling you, all of you should come and get your manual, all of you should, if you don't come and get your manual, start posting your scores. So please, all these things we are doing, the essence of it is as you go, try to meditate on it, put your own ideas to it, then you come up with what you want to present to them. So it's not much to give you what we have there. So with that said, please give us questions from our dynamics question. Let's do it on it.
So the answer to that question is everything. Now, it's ready. The answer is now that
Alright, I want to read. You know one thing? Everybody's just like a lot to say. Okay, look. There's a reason why you see people enter school at the end of this and will not finish. Yes, at the end of this, do you think everybody that enters school is going to finish at the same time? No. So everybody shares is not the same.
Wrap it up.
So please, look at that question from our dynamics. Look at that question.
Dynamics question. If you want me to do going from X in one of math.
The one of mass. What do you all have the question PDF from that dynamics? So, please, let's go. The work of mass. The work of mass is 620. Please see what you do for me, eh? Check that your PDF on the part of the client plane. Check for questions on the client plane. Let's solve 2 questions there so we can do maths. Let's solve. Which one? Please, that's the noise. Hello? Hello? Please. Yeah, hello, see, can you hear me? Please, this class is getting noisy. Please, if you are tired, you know it's not easy. But if you are tired, you go and eat. Flexion or stretch your head, then you come back. So please read the body of mass, eh? Yes. Please, you have this question that she's reading. Right. Reading. Yes. This is going to bring what do we get? But the body of mass 6 kg, that our general group, but you can write now and then you read. So I think it's the last question we treat today. The body of mass 6 kg, moving with a velocity of 15 meters per second, is suddenly hit by another body moving in the same direction. Look well. Number 6. Please, all the questions there under dynamics. If we finish this one, all the questions there under dynamics, make sure you solve everything. Yes. You will submit to me. Please do it on the 20 leaves. Now, what I want to promise you is this, I will take my time, go through all of it. Yes, all the questions. The highest score there, I'll be giving money for it. Don't worry about the much. Don't worry about how much. I want you to be motivated. I will come to class like on the Saturday, like this. We'll announce the first, second, and the third. Then you will not hear how much you're giving the person. So take your time, solve all the questions here. You will submit it on Friday. Yes. Or possibly, I think we'll do it this way. Next week Saturday, you submit it. So that the upper Saturday will call the results. Yes. All the questions there, all the questions on dynamics. You know another good thing about it, you will win prize. And the important is that if you're able to solve all those questions, there is no question you enter exam hall and see other dynamics that will look difficult. That's it. The essence of all this assignment, you see them giving you solve manual, do this one, password. It's so that when you enter exam hall, it will look like play. But if you're not doing it, maybe you always say after I will do it or you copy people. When you enter exam hall, it will look big deal to you. So take time and do it. As for the price, don't have that. I will definitely give you the price. So I said a body of mass, 6 kg, question 6. Under horizontal dynamics, so this is the last one. The body of mass, 6 kg, moving with a velocity of 15 meters per second, is suddenly hit by another body, moving in the same direction. Hereby changing the speed of the former body to 15 meters per second. Full stop. What is the impulse? A body of mass of 6 kg moving with a velocity of 15 meters per second is suddenly hit by another body moving in the same direction. Thereby changing the speed of the former body. That is, you now give it a new speed, which is v, final velocity. But then the speed of the former body is 50 meters per second. They are now asking us what is the impulse. The body of mass 6 kg moving with a velocity of 15 meters per second is suddenly hit by another body moving in the same direction. Thereby changing the speed of the former body to 15 meters per second. What is the impulse? Thank you. Now we know that impulse. Do you still remember that the second law of Newton, solution? The second law of Newton states that the rate of force, the force applied to a body is directly proportional to the rate of change of momentum change. And we said that by the time we do this, because we have equal to kmv over c, and this is the dimensionless constant, which is 1. So we now have that m equals to mv over t. If this crossover, we now have ft equals to mv. Please have it in mind that everything you have here is impulse. A situation where they did not give you force, they did not give you time, and they tell you that you have mass and you have velocity. What it simply means is that all this ft, everything knowledge, just for ft means the sentence as impulse, I equals to mv. And remember that when we started this with change in v. All these things you normally see us doing, like the equation we say equals to mass and velocity. Have it at the back of your mind that somewhere there is changing. And changing means the final one minus the initial one. So that means that this is the sentence as saying mv minus mv. Are you seeing it? Yes. And this is the sentence as saying m into v minus u. Are you seeing it?
Yes.
Is it confusing? No. And this is not the sentence as saying the mass given is what? 6. The final velocity is what? 50 minus 1 for me. 50 minus 15 is what? 35. I have punch. 210. That was my impulse. And you need to know that the unit of impulse, look at this. Newton, seconds. Show me? Yeah. So the unit of Newton, the unit of impulse, is simply Newton seconds. Very important. Please, I want you to believe me that if you are following the principle we are using to teach you physics, you will definitely succeed. Like you enter the exam with zero confusion. Live with zero confusion, because what we are trying to do is not just to solve questions, we are trying to give you principles and concepts behind it. So do the assignments. By next week Saturday we'll collect it. Then on the other Saturday, we'll store it and give our mark.
Once you win the prize, listen. Once you win the prize, you now come let us share it. Once you win the prize, now come let us, because you need blessing from me. If you share it now, not everything. When are we going to go break for this year? Please, don't worry. Maybe by 24th. Hey, Grandma, please, that's my number. So once you message me today is your first day, you get auto reply, then you use the group. When the peace of the Lord is in the food of mathematics. No, mathematics has a mood. Is it not? So be in the mood of mathematics. Okay, yes, when you boss on you know, you can buy boss and come back. A boss here is outside. You can boss it and then come